This is section 5.5, part 1, and we're going to be talking about special factoring cases. So this is where those shortcuts that we learned for multiplying, like multiplying a binomial squared or a difference of squares, this is where those shortcuts are we're really going to have to know them because we're actually going to be factoring. So today we're just going to focus on a binomial squared. So let's remind ourselves that if we have something like this, something plus something squared, we know our shortcut that we can just do the first term squared plus 2 times the two terms plus the last term squared. Similarly, we know that if we have the same thing but we have a subtraction sign in there, the only thing that changes is it's minus 2ab instead of plus 2ab. So in the past, I've always had you start off with that. That's the factored form. So this is the factored form over here on the left, and the other side is the expanded or multiplied out form. So in the past, I've given you the factored and you have to go to expanded. Now we want to be able to factor our expanded form and go back in the other direction. So today we're going to be going this way to factor them. So let's do a quick example while we're looking at these shortcuts. Let's start with a really simple one. If I gave you a problem to factor and it was x squared plus 6x plus 9. Now you could think of it your old way of factoring. What multiplies to 9 and adds to 6? And it would still work, but we just want to look at why it works right now. So what we have here is this is x squared. Our last term is a perfect square. It's 3 squared. Oh, doesn't look so good. And then our middle term should be 2 times these two things. So this one should be 2 times x times 3. And 2 times x times 3 is 6x. So this works. And if we factor it, we're going to just put those two terms that we found in our parentheses and square it. So this is the factored version of that trinomial we started with. So the first examples we're going to do, I'm not even going to, the book doesn't make you factor it, but we might as well factor it. We're just going to determine, is this a perfect square binomial? Because if it is, we can use our shortcut factoring method now. So we're just going to determine if these are perfect square binomials. So if these are perfect square binomials, the following pattern should always hold true, just like we just looked at. The first and last term should be perfect squares. My first term is x squared. I'm going to put the x in parentheses just because it makes it easier to factor it later on. So our first term is a perfect square. Is our last term a perfect square? Yeah, 25 is 5 squared. So if those are both true, then all we have to check is the middle term either 2 or negative 2 times the first thing I had times the second one. So the square root of the first and third term. Well, 2 times x times 5 is 10x. And that is my second term. So this is a perfect square binomial because my rules held true. The first term was a perfect square, the last term was a perfect square. If I found those square roots and multiplied them together, x times 5 times and then multiply it by 2, I get the middle term. So it's yes, and then if you want to factor it, you just take those two things you had in the parentheses, put them in a binomial, and square it, and you're factored. Let's try another one. 4x plus 16 plus 3x squared. So the first thing you always want to do when you're trying to factor is write things so that your, what word am I looking for here? The powers go from greatest to least. So the degrees go from greatest to least. So let's rewrite it so the 3x squared comes first, then the 4x, then the 16. So always rewrite it. And yes, I mean rewrite it, so you have to write down the problem and then rewrite it. So let's check if this is a perfect square trinomial. Our first and last terms should be perfect squares. So I can see 16 is a perfect square. That's 4 squared. What multiplied by itself equals 3x squared? Well, nothing times itself equals 3. So I can't get this one. This one's not a perfect square trinomial. So this one already failed the test. We cannot factor this using our shortcut for perfect square trinomial. We could try a C method. I'm not even sure it would work. It might work. I'm not sure. I haven't even tried this one. So, but we just know that we cannot factor this using the perfect square trinomial shortcut. You might still be able to factor it, but you'd have to use a C method. Let's try one more. We're going to determine if this is a perfect square binomial. And if it is, we'll go ahead and factor it. 100y squared plus 81 minus 180y. So remember, like we just said, we have to write these in order from greatest to least power first. So we're going to leave the 100y squared first, but we want to switch the spot of our other two terms. We want minus 180y next, and then plus 81. So let's check our requirements here. The first and the last term have to be perfect squares. So let's see, is there something that multiplied by itself would equal 100y squared? Well, 10 times 10 is 100, and y times y is y squared. So I think if I do 10y and square it, I would get 100y squared. So the first term works. Is the third term a perfect square? Yeah, we know 81 is a perfect square. It's just 9 squared. So 2 out of our 3 requirements are there. First term's a perfect square, last term's a perfect square. Then we want to make sure that I should be able to do either 2 or negative 2. Since I see a negative right there, I know I'm going to do negative 2. Negative 2 times what I have in my first parentheses times what I have in my second parentheses, and it should equal my middle term. My middle term should be double the square root of those other two terms. So let's see, negative 2 times 10 is negative 20, times 9 is negative 180, times that y, whoops, I forgot the 0, 180y. That works, that's the middle term. So this is a perfect square binomial, and if we wanted to factor it, we would put our first term from here, our second term in a binomial. Since there's a minus right there, it's going to be a minus in here, and we square it. That's it. 10y minus 9 squared. All right, let's do some more, and we're just going to factor these. So same kind of problems. Let's see, x squared minus 10x plus 25. So let's check our rules. Are the first and last terms perfect squares? And if you want to write these rules out, a perfect square trinomial will always have the first and third term are perfect squares, and then the middle term has to equal either 2 or negative 2 multiplied by the square roots of those first and third terms. So if you want to pause and write those down, that might be a good idea if you like having a list wrote out like that. So let's check. Are our first and third terms perfect squares? So let's look at x squared first. Well, that's a perfect square. That's x times itself. I know it seems silly to write that, but you want to make sure. Is something times itself equal to that first term? Last term. Is there something times itself that equals 25? Yeah. 5 times itself is 25. So then let's see. Is our middle term negative 2? I knew I needed to try negative 2 because of that negative right there. Is it negative 2 times the thing in my first parentheses times the square root of the last term, the thing in the second parentheses? Well, that is negative 10x, and that is my second term. So then I just put in my binomial, I know it's going to be a minus sign because of that minus sign, and I put my first square root and my second square root, x minus 5, and you square it. That's it. I have 3 more examples for us. We're going to try 16y squared plus 56y plus 49. Alright, so let's see. Are my first and third terms perfect squares? What times itself would equal 16y squared? Well, 4 times 4 is 16, and y times y would get me y squared. So 16y squared is equal to 4y times itself. Is my last term a perfect square? Yeah, 49 is a perfect square. It's just 7 times 7. So let's check. Is my middle term positive 2? I know it's positive because of that positive sign. Times 4y times 7. 4y and 7. Well, 2 times 4 is 8. Times 7 is 56. And I have a y. So that equals that. So to factor it, I am going to have a plus because of that plus sign. And I'm going to put a 4y and a 7 in my parentheses and square it. So it's really nice if you notice that these things are a perfect square trinomial. I mean, this would have been a really yucky one to do AC method on. We would have ended up with the same answer, and it would have been a horrible process. We would have to do 16 times 49. Blech. It's a good thing we know this method. All right, 2 more examples. Negative 20xy plus 4y squared plus 25x squared. So from looking at this one, I know I need to reorder it because it doesn't really matter which term you decide, which letter you decide to do from greatest power to least power. But right now, neither my x or my y is written from biggest power to smallest power. So I usually just like to do x's first, and that's standard form anyway. So I'm going to write 25x squared first. That has a 2 power of x. This term has a 1 power of x, so minus 20xy, and then this one has no x's at all, so it goes last. So I just decided to do my x's in order from biggest to smallest. This would still work if you did the y's in order from biggest to smallest. So let's check the requirements of a perfect square trinomial. Is my first term something times itself? What times itself is 25x squared? Well, 5 times 5 is 25, and x times x will get me x squared. So this is just 5x to the power 2. And 4y squared is 2y to the power of 2. Because 2 times 2 is 4, and y times y is y squared. So let's check if our middle term makes this work. Is our middle term negative 2, because of that negative sign, times the thing in my first parentheses, times the thing in my second parentheses. Those are the square roots of the first and third term. Well, negative 2 times 5 is negative 10, times 2 is negative 20, and I have an x and I have a y. That's exactly my middle term. So to factor it, I write my 5x and my 2y. I know it's going to be a minus because of that minus sign, and I square it. Let's do one last really tough example. We are going to factor negative 4y squared minus 144y to the 8th plus 48y to the 5th. So, like I said earlier, we always want to write these in descending order when we look at our powers. So I only have y's here, so we want our y's to go in descending order. So I'm going to write the negative 144 y to the 8th first, the positive 48y to the 5th second, and the negative 4y squared third. So, we haven't been mentioning this because I never made it part of any of these problems until this one, but remember, whenever you're factoring any kind of problem, you always want to see if you can factor out any, that's supposed to be like a dot dot. You always want to see if you can factor out any common factors first. And remember that rule that says if our first term is a negative, we want to factor out a negative out of everything. So we're going to factor out a negative. I think 4 fits into all three of those numbers. And we can also steal a y squared from all three of those guys. So let's see what we're left with. Negative 144 divided by negative 4 is 36. And they've got 6 x's left. 48 divided by negative 4 is negative 12. And they're going to have 3 y's left. And negative 4 divided by negative 4 is positive 1. And I also took the y squared, so negative 4y squared divided by negative 4y squared is just 1. So you have to write that 1 on there, plus 1. So all I've done so far is I factored out a negative 4y squared from all three of those terms. Now we want to keep seeing if we can factor. Let's see if we can factor this. And let's see if we can use the perfect square trinomial shortcut. The reason I would maybe even want to know to check for that, if this was just like a random problem given to me, is if I see that the first and the last terms, at least their coefficients are perfect squares, 36 and 1, those are perfect squares, then I might think, okay, I should try this perfect square trinomial shortcut. So, remember that we're going to keep the negative 4y squared out in front. So just don't forget him for now. I'll just like bring him down here maybe so I don't forget. Just don't forget anything you factor out's got to stay in your problem. So let's check. Is our first and last term, are they both perfect squares? So what times itself would equal 36y squared, y to the 6? Well, 6 times 6 is 36. And isn't y to the 3 times y to the 3? Wouldn't that be y to the 6? Because we add up those exponents. So this first term's a perfect square. My last term, 1, is a perfect square because that's just 1 times itself. Which means that my second term should be negative 2 times 6y to the 3 times 1. Well, that is negative 12y to the 3, and that's my middle term. So remember when we are factoring this, we have to keep that negative 4y squared out in front, and then I can set up my squared binomial here. So I've got 6y to the 3 and 1, and since it had a minus sign before my second term, it's going to be minus, and I have to put the squared outside. That is it. That was a tough one. All right, come to class with questions. I don't have any tries, so just come ready to do a couple warm-ups tomorrow.